Yeah, good morning and nice meeting you, ladies and gentlemen, on this virtual presentation. Initial hiccups, I'm a bit sorry about it. Yeah, the presentation is about the cyber attack kill chain based analysis. Cyber attack, this is basically, I'm coming from the industrial control system attacks. Mainly focusing on the process industry. Um, uh, I am basically a functional safety consultant working for Petroleum Development of Oman here in Oman. And I'm involved in the standard settings in both ISA 84 and ISA 89. 84 is the functional safety standard, and 89 is 99 is the a cyber security standard for industrial control systems. So this presentation is about kill chain based analysis, which means that looking at the cyber security attack from an army kind of point of view, and how if someone some army has to attack someone, how they plan it and what are the processes. And similar way, we can emulate that model for cybersecurity attack also, because it is not like a functional safety where you have hardware failures and systematic failures, which can result in hardware failures or random failures, whereas this is a planned attack. So those models which we use in functional safety cannot be applicable, is not applicable to these kind of attacks, which are man-made or planned attacks. So a better way of looking at it is a military-based methodology, wherein there is data collection, then they design the attack, and then they go and attack it. Okay. So that is the basis of this presentation. There are two main models. One is a basic preliminary model, and then that model was more or less okay for an IT attack. But when it comes to an OT is operational technology, where this industrial control system comes. So when it comes to an OT attack, that model has to be expanded, because they have to come either through IT or to the network, to the OT network, which is a bit difficult. So when they come through IT, they have to plan many more things apart from the initial attack steps. So this presentation is mainly elaborating all those attack steps, and then mapping those attack steps to a couple of attacks that has already happened in the industry. So ICS safety and security. So industrial control system security is critical to maintain safety. You might have come across these safety integrity levels and all for the safety system, where we find out the failure rates of devices, and then we fix the risk when this device doesn't function, and based on the consequence and the frequency demand on that, we fix the risk. We call it SIL, safety integrity level, and then we go back and design to match that safety integrity level. We call it probability of failure on demand. So so we fix the risk, and then go and design our devices so that the reliability is high such that it meets the required risk. So that is mainly on the safety side, but the whole design and whole setup is not of much use if you don't have a clear control system security. And this industrial control system security is becoming very important. because there are a lot of attacks, and nowadays it is quite easy to do it, because there are snippets available which can be used easily, assembled together to carry out an attack. The more and more we advance in security, the more and more the attackers also are advancing. However, when you compare with safety, the security prevention and mitigation approach should be different, since failure and attack mechanisms are different. When it comes to safety, it is simply random hardware failures which can fail dangerously, and then which will not perform the function. And so we go for high reliable devices or redundant devices in order to mitigate that. But here the whole thing is different, because the attack mechanism is different, because some human is mostly behind this attack, and he is going to carry out the attack. It is nothing to do with random hardware failure or anything like that. In safety failures, systematic soft and random hardware failures. The security failures and resultant consequences are because of planned internal and external attacks. Yes, security failure mechanism is different from safety. So that's the first point. So the red hat guy is behind the attack. It is not a hardware failure or a systematic failure. Cyber attack planning stages are similar to military attack plan. So that's what they gather information, they map out your system network, they find vulnerabilities, and then design a malware in order to exploit those vulnerabilities, and then install them. And once they successfully install their malware into your system, most of the cases a backdoor opens for them, from where they can command and control your system, and then take the action in order to achieve that objective. Command and control is, all these steps, there are 7 steps, 7 phases here. In an attack, it is not necessary that someone has to go through all these phases. Maybe they may skip 1 or 2 depending on methodology of the attack. And it is not always necessary that they should get a command and control in place. Later in the slide, I will just show you how without command and control one of the attack has happened. Everything was packaged in the malware, and it did its job of attacking. Lockheed Martin came out with the general cyber attack model that you see on the right. So what are the phases in this attack? Intrusion kill chain. Sorry, that is the first phase is reconnaissance, second is weaponization, third is delivery, fourth is exploitation, installation, command control, and action objectives. So reconnaissance is in the military term, as you see it, research, identification, and selection of targets. Weaponization is pairing remote access malware and exploit into the delivery payload, that is, they create the malware. And then delivery is through either some kind of a delivery. It can be from the command and control center itself, or it's from the email attachments, websites, and USB drives. In one of the attacks, the attacker went to the vendor websites where the vendor files or patches and files are stored, and he put his malware there. Whenever someone downloaded that patch, which they think is a genuine vendor patch, had that malware. So various types of deliveries can be used, and one of the easiest one is USB drive, and then giving it to social engineering, just throwing it out, and then someone picks it up and puts it into the system. If it's allowed, USB is allowed. Exploitation is the vulnerability exploitation. If you look at the sophisticated attacks, the vulnerabilities are zero-day vulnerabilities, which means that vulnerability was not known to either the vendor nor the user. So they found out a vulnerability and used it. So those kind of vulnerability exploitation. Installation, they once you plug in this USB drive, it gets installed there, and then it opens a door through probably through the internet or some other method if command and control is required for that. And without, as I said, without command and control also you can do an attack, packaging everything into a malware. Then the attacker has got hands on your keyboard, and he can do whatever he want. He can extract data. He can in the ICS, I mean in industrial control system case, it is much more dangerous that he can manipulate controls and safety, and then he can create a hazardous consequence. Yeah, this we have seen it. Triggers which takes action on the target network and exploits vulnerability. Yes, right. So these are the initial stages proposed by Lockheed Martin company, but then that was not fully enough because when it comes to industrial control system attack, one of the main thing is to stay in the system for long, to identify which is the control system and which is the safety system, which workstation is connected to the safety system, and which one is connected to the control system. Those kind of exploration is required. So you have to stay a longer period, and then so the later researchers came out with the detailed phases which contained 12 phases of it. So the first phase is reconnaissance. Of course, you have to get details about it. Weaponization is the same. Then defense evasion is very important. Attack techniques by advisory should, I mean, that it's not just cakewalk for, it's not going to be a cakewalk for them. It's there is going to be defense. There are going to be firewalls, etc., etc. So you have to evade the defense, and also there is going to be the system owner is going to look at the logs, etc. And so you have to hide yourself, camouflage, so that you are not detected, and you have to stay for long to find out where exactly the potential point of attack is available. So defense evasion, and then delivery is the same. They can do it through email attachments, use drives. Exploitation is similar to the earlier one. And persistence is very important. This is what I said. The attacker comes in, and then he has to stay, and he should be able to map your network architecture. Then only it is easy for him to go and attack it. So persistence is important in ICS attack. And command and control, of course, it may be maybe you need a command and control, or you may not be in command and control. Pivoting is also very important. Then if he comes into the IT system, he has to go to the OT system, and he has to tunnel through the network and look at OT systems which can be air gapped. Then discovery. The discovery is where he has to find out which is the right system to attack. Suppose I want to attack an SIS system, safety instrumented system, that may be connected to a workstation, and that workstation may run on a PC. So he has to discover that particular PC before he delivers his malware and then attacks it. Finally, it is execution. And lateral movement. This allows advisory to go through the network and search for systems. Privilege escalation is again important. Again, not everyone in an industrial control system will be able to configure industrial control system or the safety instrumented system. So he should have a methodology, or he should build in his exploitation to get higher permission in order to configure it, so that he can change and do it. Credential access techniques used by attacker. Yeah, they are related. Privilege escalation and credential access is related, because credentials has to be high. I mean, higher credential has to be procured or to be raised so that he gets a privilege to attack. And then he can do a target manipulation, which means that he can change the control system output set points, or change the safety instrumented systems set points, so that he achieves his goal of attacking it, or getting an impact out of it, or creating hazard. So this is the general ICS architecture that you will be familiar with. Top of it is IT side, and there is a demilitarized zone in the center, and then any command from there passes to the OT side through this demilitarized zone, and there are DCSS and SCADA systems and things like that. So let's look into one of the attacks which is quite famous, which is Triton attack, where in Saudi Arabia, a petrochemical plant, Triconic system. Triconic system is one of the pioneers in safety instrumented systems. They were the leaders in safety instrumented systems, and they were attacked. It was a surprise. The attack managed to place a malware code into the Triconic process safeguarding system. The attacker gained access to the safeguarding system engineering workstation and delivered the payload to the safeguarding controllers. So these, on the right side, you see what you see is the safeguarding controllers. We call it programmable electronic devices, PLCs, for programmable logic controllers. And on the left side is the engineering workstation. So configuration on those controllers are made from this engineering workstation. So in order to attack the controller and sabotage the plant, the attacker has to get an access to the engineering workstation. So and the protocol that is used between the engineering workstation and the Triconics controller is called TriStation protocol, and that is a proprietary protocol. So he should be aware of the protocol in order to send his malware to the TriStation. So all this was done, and the malware was delivered to the EWS engineering workstation, and it contained all these files, and from there it went injection bin and IMain bin went to the controller, and then changed the logic of the controller. Yeah, but the attack was not fully successful because the Triconics had a redundant controller, and when it was checking its image, there was an issue with the image after the attack, and the plant went for a safe shutdown. So, but for that, the attacker might have created a catastrophic consequence in the plant. Reports say how it went on. Reports say that external sophisticated attackers were in the IT network from 2014. Triconics attack happened in 2017. So see the time period for how long they were there, and how much information they have extracted in order to map the full network and see where exactly their target is. It is said that access to the ICS side was through a firewall hole. This attack again looks like a state-sponsored attack. So in a state-sponsored attack, you have unlimited resources. So so it's very difficult to prevent a state-sponsored attack of this kind. The next attack that we are going to see is Stuxnet. That is also similar state-sponsored one. They managed to install Triglog execute malware in the ICS EWS, which is the workstation, and found connected controllers using UDP ping over port 1202. This is where sorry. Yeah. This is where how to find and this is an engineering workstation. You will come across many of the boxes, but you have to find exactly which is the engineering workstation that is connected to the Triconix controller in order to carry out the attack. So this is how they did it. They everywhere they used to send an UDP ping, and where the port 1502 responded, they know that okay, this is a system which is connected to the Triconix. The .exe checks controller for run state and program mode and delivers payload files, injection bin, and IMAIN bin. Again, the controller has to be in program mode in order, that's what the reports say, in order for delivery. But once you deliver it, even someone changes from program to run mode, then the delivered inject bin and IMAIN bin can put it back to program mode to execute their requirement. So that's one of the key learnings from there. You just should not keep your controllers on program mode, but that is mainly the safety controllers. Inject bin exploited 0 to a vulnerability, which means that none of them know this vulnerability, but the attackers were able to find this vulnerability. To write IMAIN bin to the firmware, which is malicious code. This allows firmware changes and safeguarding modifications, and attacker gaining full control of the SIS. So now he delivered the payload, and he the controller is been overwritten with his code to do whatever he wanted to do. In case controller failed, Triton will attempt to return to its run state. If attempt failed, yeah. In this process, what they have intelligently done is, if the controller or the Triton controller failed, then it will again restart it and bring it back to run mode. And if it fails, this program will overwrite itself to cover forensics, to cover detection. The attacker is capable of carrying out attacks by manipulating the safeguarding PLC and the process to unsafe state by tampering with the SIS logic. Yeah, that is what is his final goal, and he could achieve it. But in this case, he didn't, because it was the redundant controller which spoiled the whole thing, which was trying to check its image, and that image, there was a difference in image, and it went for a safe shutdown. So the second one is the Stuxnet, which we are very familiar with. It's an Iran facility, where nuclear facility. The delivery was through USB and laptop, which we are not very sure what exactly, how it exactly it is, but it was through social engineering. Malware replicated in, it just went on replicated in various machines. And that vulnerability is from Windows, which is printer spooler RPC privilege escalation vulnerability. It again extracted information, and in this case, in the Triton case, there was no command and control, and in this case there was a command and control. Everywhere it went, it opened the backdoor to the person who is attacking, so that he can study the whole thing and then manipulate the attack. It is said that the initial Stuxnet purpose was just to open this backdoor, and second version of the Stuxnet was delivered through the backdoor, and then that only did the actual attack. It was looking for WinCC software. They were using Siemens PLC. Yeah. Okay. So Iranian uranium enrichment was in a high-profile project. Yeah. So it is said that the facility details were leaked out by dissident groups. The attack weaponization was by malware injection through removable media. So that covers the phases of reconnaissance, weaponization, defense evasion, and delivery. Malware exploited a couple of Windows system vulnerabilities, which I said, the spooler vulnerability and RPC vulnerability. It repeated the exploit and installed itself in phases, compromising number of systems until it activated internet access. That is where the backdoor was opened and reached out to the attacker's command and control servers. So this covers the phases of exploitation, persistence, command and control. So it to other air-gapped systems, it also exfiltrated data and sent data to attackers to map the network. Once it, it is said that the network was mapped in such a detail that Even the users or the plant guys didn't know this much of detail about the network. So they were able to extract so much data and map the network so well so that they can plan their attack precisely. Once it found the machines running WinCC schematic software, it is ready for the attack. Okay, this covers the phases of pivoting, discovery phase, execution phase, and lateral movement, where they moved from one network to the other and until they found that WinCC schematic running machine. So this attack is called man in the middle attack, where he had access. He was in the center of the network, and he was able to command on both sides of the network. Position itself as a man in the middle, manipulating Siemens Step 7 program to control its output, increasing centrifuge. How they succeeded in the attack was they increased the centrifuge pressure and speed, and they just manipulated the speed so that you don't get that critical speed and critical pressure in order to get the right output from the uranium. So that is how this was attacked, and they successfully attacked it, and they pushed the program quite far behind date, and so Iran has to recover back. It will take a lot of time to recover back. So this was a successful attack. The Triton was not a full successful attack, but it was a very interesting attack, wherein Triton X was attacked without a command and control, and that's a different attack. And this is an attack which was very successful, and everyone started looking at this attack and trying to learn lessons from this attack. So in the man in the middle and manipulation covers privilege escalation phase, target manipulation phase, and objective realization phase, which finally they achieved by changing the parameters and then changing the process in order to make the process fail. That's the end of my presentation. Thank you very much for listening. If there are any questions, I can answer.
Thanks, Kannan, for an excellent presentation and maintaining the time. How much of these concepts have been adopted in your plans? Let's say the PDO Oman, how much of these have been implemented? You said about Triconic systems and all that. So how much of it has been done in your plans?
The lessons learned are getting implemented, but the methodology itself is not used. I am promoting this methodology for quite some time, and the methodology is not used. The present focus is on using ISA 89 methodology. If you look into ISA 89, they are also still studying this methodology, which is kill chain methodology. I think there are drafts there, but they haven't come as published. But when you look at ISA 84, there is a TR, which is a technical report which talks about this methodology briefly. So I thought that this is the better methodology, one of the better methodologies to address the risks. So I'm just promoting this. Yes.
Okay, great. Thank you very much, sir. We will let you go, and then we'll go on with the next presentation. Thank you for joining from Oman. Okay.
Great having you. Below is my email. If there is anything I can be of help, you can contact me.
Sure, we'll do that.
Right. Thank you very much. Thanks for attending.